I have it on good authority that this picture is not a Photoshop, that this really happened on this day. So I'm talking about the detection theorem. So remember, Browder's theorem says that theta j is the element, well, theta j is the element detected in the classical atom spectral sequence by hj squared, as Mark explained earlier. And it's the only element in that particular bi degree. For our purposes, we need to use the atom's Novikov spectral sequence instead, and there is a map from it to the classical atom spectral sequence. That's the tome reduction that Mark also discussed. And in the atom's Novikov spectral sequence, there are elements known as beta slash ij that he mentioned that occur in this particular bi degree. This superscript here is 6i minus 2j. And you have this for certain values of I and j. And if j happens to be, now he had two indices here. I'm following the convention that when one of the indices after the slash is 1, you omit it. That's a notational convention. So I've already omitted one of them, and I'll say that when j is 1, you also omit, if this index happens to be 1, you omit it as well. Now, the atom, the 2-line of the Novikov spectral sequence has a lot more stuff in it than the 2-line of the atom spectral sequence. And in the relevant bi degrees, there are additional elements besides the ones that we're really concerned about. So for example, in the dimension of theta, in the bi degree corresponding to theta 4, we've got beta 8/8 and beta 6/2. When we get up to the bi degree of theta 5, this is in the 62 stem, we have 3 elements sitting there. And for theta 6, we also have 3 elements. And for theta 7, we have 4 elements. And I think you can guess what the pattern is. This is essentially the pattern that Mark described at odd primes. There's a similar situation at the prime too. So to prove the detection theorem, we need to show that the first element in each of these, the first element in each list has a non-trivial image, and we also need to show that if you replace, if you add any linear combination of the other elements to the first element in the list, you're still going to get a non-trivial image. So that's going to require some tricky calculation. Now, the only one of the, in each case, the only element that has a non-trivial image under tome reduction is the first element on the list. These other elements are sent to 0. They have trivial image in the classical atoms spectral sequence. So that means a substitute for theta j in here could be the first element in the list plus any linear combination of the second of the other elements. Now there is yet another element in this bi degree that has to do with it's a product of 2 alphas, and I will say something about we have to deal with that element as well. I'll say more about that later. Okay, so this is the detection theorem. So if x is any element in this bi degree whose image in the atom spectral sequence, whose tome reduction image is hj squared, then we want to say that it has non-trivial image